So far, the collections I've shown you are not thread safe. It usually doesn't matter, but if you're running a program with multiple threads, it can be handy to use a collection to share data. But you have to use special collections that are thread safe. The concurrent skip list map is a concurrent version of the tree map. The elements are in sorted order, and you can read an element on a key value. It even supports near key matches. The concurrent hash map stores items by key, but they are ordered only by the hash value. The queue collections are probably best suited to communicate from one thread to another. There are several queues that work in slightly different ways. The concurrent linked queue is a first-in, first-out queue that can grow to whatever size is needed to hold the elements you're sending from one thread to another. The sending thread can freely write to the queue, and the reading thread can try to read an element from it at any time. With the synchronous queue, a thread can only write to the queue if another thread is already trying to read from the queue. You can have multiple writers and multiple readers, but they will be synchronized by the queue. A blocking queue is one that blocks on reads. That is, when a thread attempts to read from an empty queue, the method doesn't return. The reading method blocks, waiting for an element to be written to the queue, and then returns it. There is more than one blocking queue. The only difference is the internal implementation. Let me show you how it works. This class constructs the queue and then starts the sending and receiving processes that send integer objects from one thread to the other. The queue is a linked blocking queue. The queue itself is passed to the sender and the receiver on the constructors, and both the sender and receiver threads are started. This is the sender, the class that puts integer elements into the queue. When it is created, it stores the queue locally for future use. The run method of the thread is a forever loop that continuously puts objects in the queue. It continuously creates new integer objects with the values 0 through 5. And it puts them in the queue. It has a sleep in the loop, so it sleeps for 2 seconds, that's 2,000 milliseconds, between each element that it puts in the queue. Now that's all the sender does. It displays the integer values and sends one integer every second forever. This is the receiver. It reads integers from the queue and displays their values. It's constructed very much like the sender, except it reads the values. It uses the poll method to do the reading. The method has a timeout on it. I just set that to 60 seconds so it wouldn't ever time out. The sender is putting one integer a second into the queue, so the receiver should always get one. The receiver displays the integer value. Then it sleeps the number of seconds of the integer value before continuing the loop. The sleep time varies from 0 to 5 seconds, so the two processes are never synchronized. Here's what happens when they run. At first, the sender is not writing as fast as the receiver is reading, so the receiver has to wait until an element is put into the queue. But the longer wait times of the receiver eventually take their toll, and the sender gets ahead. Integers start to back up inside the queue, and one is available every time the receiver loops around to read one. Two processes can be completely asynchronous and access the queue whenever it's convenient. That covers the basics of collections. A few other things can be done, but they're nothing more than variations on the things that I've shown you. Next, we're going to look into some deployment issues, some ways of getting class files to the users.